Okay, in this video I'm going to give you an example of drawing the waveform for an MLT3 signaling. This is used in 100 base TX Ethernet. And the idea here is that a 0 bit is going to give you no voltage transition from the previous voltage, and a 1 bit is going to give us a transition through a sequence or a cycle to the next voltage in the cycle, where we cycle from plus V to 0 to minus V to 0 to plus V, etc. Okay, so we're sort of cycling up and down, up 0, down 0, up, and we cycle through those. And so we're interested in drawing this picture here for some bit pattern, and it looks like I have the same number of bits as I do have bit periods here. So there's 1, 2, 3, 4, 5, 6, 7, 8, about 16, so 8, yeah. There's 1 bit for each of these, and I'll do a problem which is distinct from the one in the homework here. I will give some bits, maybe like this. Whoa, no 2s allowed, John. Maybe something like that. And I think I need to know what the previous voltage was here. So let's just, so the problem doesn't state that, but clearly we do. So we'll assume that our previous voltage was a +1. Okay, and so a 0 means no voltage transition. I'm going to go ahead and use a little bit thicker line for my... So a 0 means no voltage transition. A 1 means we go down to the 0. We cycle through. Another 1 means we cycle through down to minus V. A 0 means we stay where we're at. A 1 means we cycle to 0. Now we cycle to 1. Now we cycle back to 0. Zeros stay the same. Now we cycle to a negative V. And a 0 means we stay the same. Cycle. Cycle up to a plus V, stay the same, and then back down to 0. There you have it. So this is an example of drawing the waveform for an MLT3 bit pattern. And it's also quite straightforward to take a given pattern and extract the bit sequence from it. Okay? And again, here we had to assume that the previous voltage was a plus V on this one. Had I assumed that it was something different, the pattern would look quite different. Okay? Let me go ahead and quickly draw for you what it would have looked like had I started at 0. Okay? Suppose that I had started at 0, and I'll try to bring the same bit periods down here. If I had started at 0 on this one and had a 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1. If I had started at 0, and now again I have to assume that the previous non-zero voltage, let's say, was positive. Then when I get a 1, it'll cycle to a negative, then back to a 0, stays at 0. Now cycle to positive, cycle to 0, cycle to negative, stay the same, cycle to 0, stay the same, cycle to positive, cycle to 0, stay the same, and cycle to negative. Okay? So it could look quite different if we had started differently. And there's a distinction between the voltage that we're starting at and the last non-zero voltage, so that you know where you are at in the cycle. Okay, hope this helps.